Good morning, friends. Welcome to the Python solving problem. Myself, I'm B. Tarun, 2022 passed out mechanical graduate and a Python full stack developer. Now, let us solve a problem of matrix using Python. There are two steps to follow. First, we need to approach the problem and understand the logic and then implement it in a code. Now, let us solve the problem in detail by step process. This is the problem. Here, it's a n into n matrix means if there is n number of rows and the n number of columns is present. So the rows will follow a logic and the columns will follow another logic. Let us consider this row. It follow a logic of sum of previous two elements plus 2. How means let us take if there is no previous element, let us consider as 0. Here 1 plus 0 equals to 1 plus 2 equals to 3. So 1 plus 2 plus 0 equals to 3. In the same way, 3 plus 1 equals to 4 plus 2 equals to 6. 6 plus 3 equals to 9. 9 plus 2 equals to 5. In this way, 6 here the past two elements are 6 plus 3 plus common element 2 it is equals to 11. In the same way, 11 plus 3 sorry 11 plus 6 plus 2 equals to 11 plus 6 equals to 17. 17 plus 2 equals to 19. In this way we get 3 6 11 19 in the same order up to n row. Now if we follow the columns logic, let's consider the number as 1 2 6 15 31. That's our 1 2 6 15 31 and 56 92. If we consider the difference between these two numbers, it's 1, and the difference between the 2 and 6 is 4. In the same way, difference between 15 and 6 is 9, and 15 and 31 is 16. 56 and 31 is 25. And in the same way, 56 and 92 is 36. If we clearly observe these differences, it's the square of n terms. Means 1 is the square of 1 into 1 equals to 1. In the same way, 2 into 2 equals to 4. 3 into 3 equals to 9. In this way, for incrementing every order, we should add its square to the previous elements. Means here the nth element will be 2. So 2 square equals to 4. The 4 should be added to the previous element. In the same way here 3 into 3 9. 9 should be added to the previous element 6 to get 15. In the same way 16 is added 15 to get 31. In this way we follow up to n iterations in the row. In this way we get matrix. Now let's solve the level 1 or the first problem in the matrix to generate this series. Let's first approach the series of a row. Here I have taken the first number as 0 and second number as 1, and the column start is 1, the first matrix is 1. For I in range, because the first index has to be declared by us, 1. 1 should be declared by us. So 1 from basis on 1 we have generated the series. So first number and second number, that is second number is 1 and 0 plus 2 will be added as a first element. In Python 1 is referred as second element. Here it's 1 as we consider as 0, here 1, and 3 becomes 2, 4 becomes 3. So Let us consider these row indexes for minus 1 means 1 equals to 0, 2 equals to 1. In the same way, 20 equals to 19 for the last element. For first index, 0 plus 1 plus 2. So we will add the first row matrix 2. So it will add 2. Previously it contains 1 and now it contains 2, sorry, 0 plus 1 plus 2 equals to 3. And the first matrix will be appended to the, sorry, the sum will be appended to the 3, and first number will be changed as second number, and second number will change it as sum here is 3, it will change the second number, and the previous second number is 1, that will change as first number, and the same process will be done again. The sum will be second number first number equals to plus 2, it means 6. Now the second number will be has 6 and first number will be has 3. In this way, up to n iterations, we will generate a row. So after completing this loop, we will generate the first row of a series. That means if we print the first matrix, it will be 1 3 6 11, and the last element is 28655. 28655 has a first row. Now, based on this first element, for the second, we have to add one square for each, and we should generate it as a second list, or in the matrix, 2D matrix, each element has considered as a single element. And in element, there are 20 elements, again elements, sub-elements. So we have to generate this second row elements based on first. So I am generating the level 1. I mean the creating a function called whole matrix, in which I am sending this first matrix, I mean this 20 arguments as a input, because based on these 20 arguments we will generate the second matrix. Based on the second matrix we will generate the third row matrix. In this way we will generate up to 20. That is the whole matrix generated after this function. So generate whole matrix function has been created, and the first row of matrix has been sent as an argument. Now, in the whole matrix, uh, the first has been solved already. So the first matrix has been appended initially or initialized firstly. Now, as we all know that the index starts from 0, the 0 element first matrix has been declared. So we have to start from 1. We all know that each is increased by I square. If the index is here, the index is 0. For 2 1, so here I equals to 1, so I square will be incremented, means 1 square 2, and 3, 1 square 1, 3 plus 1 equals to 4. In the same way, here the 3 I will be 2, 2 square 4, 2 plus 4 equals to 6, 4 plus 4 equals to 8, 7 plus 4 equals to 11. In this way, based on I, we will increment its squares and add it to the all the first matrix. But this matrix increment is depend upon the above matrix. So after the declaration of the last matrix, after the declaration of the each and each matrix, here, yes, we have to assign the last matrix equals to inside matrix. Means here first matrix equals to last matrix. In the first iteration, it will be the last matrix. Once the for loop is completed, the increment has been declared, it will append it to the main list, and this list of 20 elements will be the last elements, and again the for loop with increment 2 will be performed. The 2 will be performed on the last matrix, means this second will be the matrix, and 4 square, sorry, 2 square 4 has been added to this matrix, so we will get this matrix as an output. Now it will assign as a last matrix, and next action will be performed on fourth based on the third matrix. Finally, the output of the matrix will be returned, and the matrix will be, see, the first element is 1, and in the first row, the last element is 260, 26, 28655. In the last row, the starting element is 2471, and the last element is 31125. 1, 2, 8, 6, 5, 5, and the last is 2471, 2471, and the last 31125, 31125. As we have successfully created the matrix in which the series we have to decide. Now, moving to the second problem, the question is next sort the orange ordered numbers in a matrix in a ascending order. Means we have to select all the numbers which is shaded in the yellow part, and among this we have to all from all these numbers we have to arrange it in a ascending order. So let's do one thing. From taking this whole matrix as an input, there is a large, sorry, there is a common thing of this orange elements. Means here I equals to 0. When I equals to 0, I mean I, for these elements I equals to 0. Here j equals to 0. These are j elements, these are I elements. Now I equals to 0, we have selected all the elements. And in the same way, for I equals to 20, we have selected all the elements. Means I equals to 19. The two row elements has been understood. For about this diagonal elements, when here I and j values are equal, 1, 1, 2, 2, 3, 3, 4, 4. So the simple logic is when I equals to j, then we have to select that element. In that way, we can clear this left right angle hypothesis, sorry, hypothesis I mean values. Now considering to this, we know that this 19th element index will be as 19, and this element I value as index value is 0. So 19 plus 0 equals to 19. In the same way, the sum of these two indexes is here 19 means I value will be 18. Here it's 2. 2 minus 1, 1. Here also 18. So we can get a logic here. Means when I plus j equals to 19, then 19, then we have to select the element. From this way, we can select all the elements where I equals to 0, I equals to 20, and here the law, here the condition is I equals w equals to j. Here I plus j equals to 19. From this, we can get the diagonal values and the upper and lower border values. Let's go through the code. Here, the level 2. Here, the level 2. There is 2 into 2 matrix, so we have to go for each and element for using two for loops. The first for loop will be elemented as rows and I. Here, we using four conditions. I equals to j, I equals to 0, I equals to n minus 1. As we are using n into n matrix, simply we cannot say I equals to 19. As I mentioned before, I plus j equals to 19. 19 can be written as 20 minus 1. Here 20 is n. So we can write in a formula as n minus 1. In the same way here we cannot write 19. N minus 1. Here n equals to 20, so we have to get the I as 19. So when the I equals to n minus 19, we have to select all the rows. That has been implemented in this if condition. I equals to j 0, 19, and I plus j equals to n minus 1. So we get all the diagonals list. Uh, diagonal. Okay. Let's print. Okay. Now let's comment this. we run the program, it will generate, see, 1, 3, 6, 11 up to 2855. After 2855, 4, 1770, 11, 1. After 4, after 28655, 4 has been selected, 17770 has been selected. In the same way, 11, 10, 9, 494 has been selected. 10, sorry, 11, 10, 949 has been selected. In the same way, the last 241, 2471 and 31125 has been selected. Okay, now the question is, after selecting these elements, we have to arrange it in a ascending order. Using using the sort method, we can arrange the elements in a list in a ascending order. So I have used a sorted method. Let's print it. In this way, 1, 3, 4, 6, 11, 11, 19, 25, 32, 87. In this way, we have printed it in a ordered way. Okay. Now let's move on to third question in this based on the same matrix. Here, given from the shaded elements, both light orange means this triangle, and orange diamond display all the numbers that are made up of repeating digits. Okay. Fr Except the white blocked cells, we have to select all the cells or all the elements in the matrix. From that elements, we have to select the numbers which have repeated elements, means any number in the any number in the any digit of a number in the number has been repeated more than once, then it should be print. Example 1 1. The 1 has been repeated 2 times, so it should be taken away. In the same way, 110, 144, 227, 338, 404, in this way. 1828, 18528 means 8 has been repeated for 2 times. In this way, we have to clear it. Now, how can we approach this? If you carefully observe means there is some logic, means here only one element has been selected. Here two element has been selected. When I equals to 0, one element has been to select, means for I equals to 0, j should be 1. For I equals to 1, j should be 2. For I equals to 2, the j element should be 3. 3 elements should be tackled. In the same way, up to 10, when I equals to 9, 10 elements should be selected. I equals to 10, 10 elements should be selected. When after the half of the matrix has been reached, the process should be get reverse. For 11 elements, it should select 10. For I equals to 12, it should select 8, 9. For 13, 8. 14, 6. 15, 5. In this manner. So, for the same rule, we have used the opposite. Based on the index values, we have generated a formula for approaching these elements. I have used four methods to get this using for loops. Let get let into the code using level 3 to approach this. Okay. Now list of elements. Okay. List of elements means all the elements have been colored light orange and dark orange, and repeated digits means 11. It should store the values 11 and 110, 144, 227, 151, 141, this. So I have created a list to store all the values and another list to store only the repeated values. So copy matrix has been not used anywhere. So now I have used a for loop. Mm. Here we have to declare first half of the matrix means n by 2 where whether the n will be odd number then the half of the value will be in a decimal, so we have to convert into integer. So first we have to divide the whole n by 2 to get the half of the matrix, and it should be converted into n to eliminate the float values. So I have used x, and here a rule should be followed up to n elements, I mean x value. X has been defined as a half of the value. Up to x, one rule should be applied. After x, another rule should be applied. In the same way, here a rule should be applied for half of the elements. Here also the rule should be another rule should be applied for another half of the applies. So I have used if I is less than x means from 0 to 9. It's taking 10 values, and from here else it's taking 10 to 19. Here total 10 values, 0 to 9, and here 10 to 9 values, 19 up to 11 to 19 is 9 plus 10, sorry 10 is another element, so total 10. For the first 10 elements it should follows for j in range 0 comma I, and the list of elements should append in the element should be appended in list of elements. Here the components will be as I equals to 0, 0 plus 1 is 1. So the only 0 element will be selected first of all. Let's take an example of 3, I equals to 3. If I equals to 3, 3 plus 1 equals to 4. Then j will be iterate from 0, 1, 2, 3. So 0, comma 1, 0, comma 2. In this way, 3 when I equals to 3, that means 0, 1, 2, 3. Here 0 will be selected, 1 will be selected, 2 will be selected, 3 will be selected. The four elements have been entered into the list of elements. And for 10 equals to 9, it should be reverse. 0 to 9 means here the increment has been done because the each and every time one increment has been done. Similarly, here based on n, where n is 20, I is 11. If you remove 20 minus here, I will be 10. 20 minus 10, 10. So we get 10 elements. Each and every time we have to decrease n with I. The same rule has been followed, and we get the list of elements. It will be appended into the list. For second double triangle means this right side triangle, here the I has been increased, but here j has been decreasing the value. Means for I equals to 0, we are taking 20 element only. I mean 19, I index 19 element only. For j equal at second elements, we have taken 19, 20, 109, 28640. So we are following a rule called n minus 1 comma n. Means here for 0 index, let's for 0 index, it means I equals to 0. We are using n minus 1, n minus I comma n. It means I equals to 20 minus I equals to 19, comma 20. It means only 19th element has been selected. Where the 19th element it is. In this way, if we take here I 5 means I equals to 4. 4 means 19 minus 20 minus 4, it's 16. 16 to 20. Here the 16th element will be it is 17th, 18th, 19th, 20. These five elements has been selected. In this way we get the formula, and the same here, the same has been reversed from I to N. Here from 11th year 11, so we should adding from 11th to N. For 12 we are selecting 12th to last. So I comma to N. We are giving the starting index and ending index based upon the logic we have to select. In this way, all the elements in this have been selected. If we print the list of elements, see 1, 2, 4, 6, 8. 1, 2, 4, 6, 8, 11. First, it will be selected and it will be selected. Now, from each and every element, we have to select whether the number is containing a greater symbol or not. The numbers are not integers are not iterable. So first we have to change it into string. Here I is a each and every number at each and every iteration. So count is called the number of elements containing 11 one digits. E- Here just they have asked the number of numbers, so there is no meaning of count. Sorry. Okay. The count has been declared as if any element more than one has been. So if we take 12511, any number count will greater than 1, then the count should be declared in this. Okay. Okay. Here the count has not used for anywhere. So let's comment it. Uh, okay. Now after changing the number into string, we can iterate it. Let's take an example of 1021. Hashtag 1021 and another number 696793. 6793. I'm explaining the two results. Let's take an example of now. First, the j will be sorry in the first iteration of this for loop, j has 1. Now, using in this number, the count of j is 2. So the times is greater than 2. So it has a repeating digits. So it will add it into a repeated digits list and it break the for loop. So no need of checking the count of 0. So it will break the loop and move on to the second number. Let's consider the second number as 6973. Now first j will have 6. The count of 6 in this 6 number in this number is 1. So 1 times will be stored as 1. 1 is not a greater than. So again for loop. Again j will be 7. 7 is count is 1. 1 is greater than 1 false. Same way 9 3. So no uh, after the completion of this iteration, this number iterations, it does not count any number more than once. So the number doesn't add to the repeated digits, and the next number will be taken as I. After completion of all numbers, we will check the repeated matrix. Repeated digit matrix, we get all the numbers 11, 33, 66, 1110, 144. These all the numbers have the digits, any one of the digits that has more than once. And we have solved problem 3. Now move on to problem 4. Here it's a bit tricky as display the descending numbers. They have given a numbers called in then they have said that they have to select the numbers which are in white cells. So we have to select all the white cells. As if we clearly mention the matrix, there is some logic. Means I have said that it has a matrix from 0 to, I have mentioned that matrix starts from 0 to 20. It means 0, comma 1, comma 2, so on. Let's 18, sorry, 17, comma 18, comma 19. Let's consider this as a matrix index. We have to select only white elements. It means for I equals to 1 to, sorry, 0 to I equals to 10, it should follow one pattern. After I equals to 11, it should follow another pattern. Let's see. For I and j, it doesn't following any pattern, right? Now, here, when I equals to 0, one element has been removed. For I equals to 1, two element has been removed. For I equals to 2, if we consider a for loop, it will select from, this for loop will select from 0 to ith element. But for the 0, we have removing one element. For 2, we have removing 2. Okay, let's I equals to 0. Then we have to remove one element. Means term should be increased by I value. I plus 1, right? If I equals to 0, it should be 1. If I equals to 5, it should be 6. Let's check. If I equals to 5 means 4, then term should be okay. If I equals to 4 means the fifth element, the term should be 1, 2, 3, 4, 5. 31, 33, 36, 41, 49. These are the 5 elements, right? How can we select the remaining elements? Now we have to remove 5 elements, right? It means we have to start from the sixth element. It means the starting has to be started from sixth. That means terms. Now let's take it's a 4 and the terms will be equals to 5. In the same way, if we remove the terms, okay, now the starting will be 5. It means sixth element. It means sixth element. And the before 5 elements has been eliminated. In the last, I mean, in the nth term, 20 minus 5 is 15. 10, 11, 12, 13, 14, 15 elements has been selected. In this way, for this, we have approached the process. Next, for 10 and 11, it should be done. 10, 10, no increment. After, here, the terms will be reached climax. I mean, after getting 10, terms should be 10. It means the first 10 elements in the starting index will be eliminated. The last 10 elements will be eliminated. When half of the matrix has completed, next the decrement should be start because we have to follow the reverse process. For 11, it should be 10. So the same 10 10 elements will be eliminated. After that, terms will be terms equals to I minus 1. Sorry, terms will be terms, not it's I plus. Okay, TERMS terms minus 1. Here also TERMS terms plus 1. Now, if we consider the 11th, 12th element, terms will be 10 minus 1 is equals to 9. It means they have eliminated the first 9 elements and only selected last one, and from the ending index 9 elements should be removed. So one element will be selected and the last will be eradicated. This has been applied on logic. Level 4 decrement. See, we have declared the half the element as x. Now I is less than x means the half should be followed. Means I have mentioned the terms as cutoff. The which part of the element should be cut off. So 0 plus cutoff. So that element will be removed. In the last way n minus 1. So the end limit will be decreased. In the same way, when I is greater than 0, 0 plus cutoff and n minus cutoff. Okay. Here, simple change is the cutoff. Here, the cutoff will be increased and here the decreased. Here, see, cutoff is increased and cutoff will be decreased. In this way, using the same for loops, just I am accessing the elements when it reaches the logic, and the final white matrix will be 3, 6, 11, 19, 32. See, 3, 6, 11, 19, 32, and the last element is 1, 3, 4, 1, 4, 2, 0, 1, 7, 9. See, based on this, the same. Here, the decrement should be checked as if a number is decreasing continuously, like 5, 3, 4, 2. Here, sorry, 5, 4, 3, 2. Here 5 is less than 4. Sorry, 4 is less than 5. 3 is less than 4. 2 is less than 4. So this is a decrement number. So it should be selected as 5, 3, 2, 4. Now 3 is less than 5. 2 is less than 5. But 4 is not less than 2. So it's not a decreasing number. So it should be cancelled. I mean not selected. The same logic has been written in Python as check whether the number is decrement. So to iterate the number, we have to change it into string. For the length of the number is 1, I mean it's the single digit number which doesn't perform it's a for it decrement. So we return false and the count is 0. Now for I in range 1 comma, so we have to check from 1. Here is the 4, 3 is the index 1. So we have to check from this to previous element. See, if integer of I is less than uh, previous element means this 3 is less than 2, sorry, 3 is less than 5, which doesn't perform any action. But here this element is not less than the previous element, then the count will be increased or count will be declared to 1, and we can break that loop to less the complexity of the program. When there is no number which is greater than the previous number, then the count will be 0 and return will be true. And if the count equals to 1 means that a number is greater than the previous number. So there is a increasing order, not a decreasing order. So it returns false. So as up to here, okay, as here each and every element will be checked. It is a decrement number or increment number. When it is a decrement number, it returns true. If true, level 4 answer list will be appended with that number. If we print that level 4 answer, the answer will be C 32, 53, 87. 8 is less than 7, 9 is less than 8, 8 is less than 5, 2 is less than 0, 5 is less than 4, sorry, 4 is less than 5, 8 is less than 9, and 6 is less than 8. 2 is less than 9, 2 is less than 6. Only these numbers in the matrix, which are in white boxes, are decreasing numbers. Now coming to the final part of the matrix. Here, now we have to divide it into two parts. That is, the black should be considered as one border, I mean the block, sorry, the dark shaded elements should be considered as a bordered elements, and the creamy shaded elements should be considered as a main elements. Now here, if you see the problem, find the largest prime number in the dark cells. Means we have to find the largest number in the prime elements. So using the bordered elements, we have to find the largest prime number. If to the prime number, each and every element in this creamy should be added and returned the list. So let's take how to solve this. Here, level 5 approach. Level 5 answer is okay. Submatrix level 5 done. Okay. Level 5 answers will be stored with creamy cells. Now let's think how can we solve this? As in the above mentioned problem, here we have incremented this and decreased. Sorry, here the cutoff will be incremented, and after this half element, the cutoff has been decreased. The same way here, the opposite. From first, it should be increased, and second, it should be decreased. And a logic for the bottom elements has been added. See, x minus terms, x. Then, if we consider this matrix, let's take a first matrix, I mean, first list example with these terms. Okay, if I is less than 5, submatrix, right. Let's copy paste this in a notepad to check. Let's take a 0, 1, 2, dot 17. These are the index. Now let's paste it. Now x will be 10 because half of the 20 is 10. X equals to 10. And here terms is count 1 means 10 minus 1 will be 9. Here n will be 20 minus 10 plus we should increase only one element means 10 plus, sorry, n equals to 20 plus 10, sorry, minus 10 plus means from half here it doesn't change anywhere because the limit has been increased from half only. See, from increasing half only. Here the last elements means from 10 to 9 will be selecting the previous elements. So it should not be changed. So plus one element. For each iteration, it should be increased by terms. If I equals to 1, it will be 8, means two elements before 10 will be selected, and after 10, it will select 2. If a terms equals to 5, when will be the terms equals to 5? At the time of index 5. Then 10 minus 5, it's 5. So the elements from fifth element is selected 62, 83, 1, 172, 616. These five elements have been selected. In the same way, 20 minus 10 has 10. From 10 to 5 elements has been selected. From 10 means here 405 to 5 elements has been selected. After here we are selecting 62 to here. From X, let's take this as the first element. Have we considered means this is the starting elements and here X minus 10 n minus X. This will be the last element, but in for loop, the last element will be minus 1. As we know, n is 20, here is the last element will be 19. So this will be the first element and this will be the last element. We can consider these two elements as a borders, means these two. And after entering this loop, means if we write if this this condition, if I equals to this or I equals to last element, means which elements will be selected, only these two. In else conditions, these 8 elements will be selected where I equals to 5. These two elements in the condition will be added as a bordered elements, means where we have to check border. Border elements 62, comma 2612. And in normal answer 5 fifth answer, these 8 elements will be selected. In the same way for first two also. In the first two, 231375, this will be the first and this will be the 7. So it two elements will be added as a bordered elements for fifth answer elements, no elements in the middle. So it returns empty list. So if we extend this empty list into the main list, it will return 0 elements or it will add 0 elements. So let's look into the code here. See, the first element, starting element and ending element has been declared. If j equals to starting element or j equals to ending element, we should add that into the border list where we have to check the prime number. Otherwise, submatrix where we have to add the prime number. So after adding this, we have to add all the elements in the submatrix to the level 5 elements. Means every time the submatrix will be assigned with new elements in the next list. First, the submatrix list will be this, and the submatrix list will be this. This should be added into the main to get all these numbers in a single list. Now, in the same way, we have to here we are increasing the count. Sorry, we are increasing the uh, terms. Means how many terms should be considered. In the same way, here the terms should be decreased. Okay. Now, after that all, if we print the border elements and print the level 5 elements, we will get the border elements as 231375143. 231375143. The last should be 27012845. 27012845. Okay, the border elements has been declared. Now coming to the orange, as I have declared this as level 5 answer. 232376 is the starting, 23237 is the starting, and coming to ending, it's 23402484. 2484. Okay, here the border elements and mm, okay, level 5 elements has been successfully, we have get all the elements successfully. Now we have to find the largest prime. Just initialize the largest prime is 0. Now, or we can take 0 is not a prime, so take 1 as a largest prime. No, we have to add no. If there is no prime number, then every number will be incremented by 1. So consider as it as a 0. Now, largest prime numbers means we have to check the largest number first. If we have started from the first number, if there is no any number in the law from the last, it will take time complexity more. So it will take a problem. So okay, anything is based on the problems. So from the from descending order, we will check if any prime number has been find in the first, then we break the loop, and that will be the largest prime number. As you all know, the prime number logic. Any number is divisible by itself, that's the prime number. Here, let's I take as a 100. Here we are iterating from 2 second element to I element, not I up to 9. If any number divides from 2 to 99, if any number divides 100 completely, it returns 0. If it returns 0, temp equals to 1. If the temp equals to 1, it's not a prime number. So if the temp equals to 0, that the prime number has been assigned to largest prime. And from this we can get a largest prime as 2251. 2251 is a prime number. So we have successfully uh, get the prime number from the border list elements. Now to all the elements in the level 5 answer, large prime number added list means every number in the level 5 answer should be added to a prime number. I have done that. Largest prime number, every element in the level 5 with I, and have appended it to large prime added list. So it will be the output. If you have any doubt, check these three outputs. So if we consider 232, see the largest will prime number is 2251. If we add both, 2251 is 2 2483 2483. In the same way, 2484 2251. 1 plus 4 equals to 5, and 8 plus 5 equals to 3. 1 has been carried. 4 plus 2 equals to 6. 6 plus 1 has 7. 2 plus 2 equals to 4. 4 7 3 5. So we have successfully got fifth answer. In this way, we have completed this matrix problem, and all the best. Thanks for watching the video. Myself, I'm Tarun, signing off. Thank you.